Okay, now we've got a database with some data. Let's create a new API controller so we can create an API endpoint and receive HTTP requests that we can then use to respond with the data from our database. That's the goal of our walking skeleton, and that will ensure that we've got a way to query and return data from our database to whatever client is requesting that data. So inside Solution Explorer, inside our controllers folder, we've already got a controller, an example controller that was created when we created this new template. And if we take a look at the things that make up this controller, certainly at the top, we have this thing called an API controller attribute. And by using this attribute, this indicates that a type and all derived types are used to serve HTTP API responses. And controllers decorated with this attribute are configured with features and behavior targeted at improving the developer experience for building APIs. So this gives us some features that help us to write less code effectively, and we'll take a look at some of the magic that this gives us as and when we come across it. But for the time being, we're just going to decorate any API controller we create with this attribute, and we'll look at what it actually gives us as we come across the features that we'll be using in our controllers. We also give our API controller a route. How does the client get to this specific endpoint? So we have to give it a route. If we do not give it a route, we won't be able to pass requests to a specific API controller. And then we also derive from a controller base, which is a base class for an MVC controller without view support. Now, an MVC controller, or Model View Controller, is kind of an old-fashioned technology or pattern now, where you would have a controller such as this with endpoints, but instead of returning an API response which typically contains JSON data, it would return an HTML page and would render the data that you get from the database on the HTML page itself before returning that to the client. But we're creating a single page application on the client side, so we don't need HTML. We need JSON data to build our view, and the view part is what we're going to be using Angular for. So we don't need the view support because we're going to use an Angular client to do that. So we just use controller base in our API controller. So let's go ahead and create a new API controller endpoint, and inside controllers, I'm just going to say add new file. And then we're creating a new class, so we select class, and I'm going to call this users controller, and press return. And just like the weather forecast controller, we're going to give this the same attributes that were used there. So we're going to decorate this with an API controller attribute, and we're going to give it a route, and in the arguments in parentheses, we open up quotes, and then I'm going to say API, inside the quotes, and then say /, and then in square brackets we specify controller. And in this case that means controller is going to be replaced with the first parts of the class name. In this case that's users. So in order to access the endpoints in this controller, the user would browse to localhost 5001 and then /API /users, and then they would be routed to this controller and the endpoints inside it. And we also need to derive from controller base, just as the weather forecast controller did as well. And then inside our controller, we can create the endpoints, the API endpoints. And we're going to have two for this example. We're going to have an HTTP GET request. And then we create the method that we're going to use to return an HTTP response to the client. So we're going to say public action result as the type of thing that we're going to return from this API endpoint. And then we specify what type of thing we're returning. Now we're going to return a list of users. And there's many different types of lists in C#, but one that we can use for this is an IEnumerable. And this is just used for a collection of a specified type. So we can say IEnumerable, and we're going to return an IEnumerable of type AppUser. And when we specify types of things inside .NET, we do so inside angle brackets. And then we give our API endpoint a name, and I'm just going to say get users. And from here we can return HTTP responses. Now we're going to return a list of our users, which means we need access to our database. And the system that we use inside .NET, if I go back to our program class, then we effectively use dependency injection to inject services such as our DB context into our other classes in our application. And dependency injection means that the framework is responsible for creating a new instance of our data context class and then disposing of that class that we inject after we finish using it. So when we inject something like the data context into our class, we don't need to worry about its disposal. We can 100% rely on the framework to dispose of it for us. So how do we inject something into our API controller? Well, we use the same method we did in our data context. We use constructor injection. And the way that we used to do this, and because this course is now based on C#12, I'm going to be doing everything C#12 way. But just in case you're looking at older code, then I'll just demonstrate how we would do this prior to C#12. So I would generate a constructor, for example, using this technique, and then I would specify the class I'm going to inject. And I would say data context, and I would give it a name of context, for example. And then I would use the quick fix and say that I want to create and assign the field context. And then we would effectively create a read-only data context field, and we would have this context equals context. And what you would often see is developers like to name private fields with an underscore, and then instead of using this, because the context is part of this class, then the list keyword is used to specify that, yeah, we want to use this thing inside this class. But a lot of developers don't like the overuse of the word lists, so they would often change it to underscore context and then reference context by its underscore context when using it in the class. So then we would have access to our context like so here. But in the C#12 way of doing things, it's much cleaner not to use this approach. And we do get the ellipses here to say, hey, there's a cleaner way of doing this now. And we could use the quick fix and say, yeah, sure, use the primary constructor. And then we've got our constructor with data context, and then we don't actually really need the private read-only field. We can just use the context specified in this way in our class. And it's just so much cleaner. So then we can say that we want a list of our users. And we could say var users equals context.users. And we get full IntelliSense and everything with Entity Framework. And we've got a table called users in our database. And we can access context.users. And we want a list of these users. So we can specify toList. And this will give us a list of users from our database. And then we can return this list of users to the client. Now, when we're using this return type of action result, then we do get some type safety with C#, and we could say that we're returning a list of, or returning the users. And this is valid code. This is fine. But when we're using an action result, we do get the ability to return HTTP